Now that we've had a real-world example of using metaballs as a force, let's get into pillaging and plundering and starting to write our own vex, our first vex functions with metaballs. So I'm going to dive in here into pillage and plunder section and call this meta weight. We kind of already saw this in the pop vop, which is a great way of going. I like writing vex, and there is a gotcha, and I'd like to describe that to you and show you how to get around it. First thing I'm going to do is just going to lay down this and give ourselves quite a few points to play with. So we have quite a few points. I'm going to put a sphere around this quickly, and then I'll put a box around that. Put a box around that, and then we will. I'm going to put a little. I'm going to put a little points from volume on these two. Oh, that's not what I wanted. Delete. Delete, tab, put a switch down, and from here we will go points from volume, and I'm going to keep this pretty like 0.14. I think was a good value for this, and that gives us a good set of points. And if you look, we start with a box, start with this, tab, switch this. And we can tab, switch, one more switch. Start with our grid first, and then we can switch over to this. Okay, so we'll start with our grid, and we've got our points, and we'll make sure that we're in like a hidden line ghost mode, which is always kind of a good way to be. Put down our friendly neighborhood's metaball, and give him a little bit of scale. Take a look at him. Yeah, there he is. Okay, and we're going to put down attribute wrangle, and we'll plug him in here. Now the function that we're going to be looking at, and I do this quite a bit, is I go float my u. U is just an arbitrary value, and what we want to look at is meta weight. And if we sit here and hover, it'll show us the usage is meta weight string file name vector p. Right? Now, P is just a position. So what we would like to do is we'd like to be able to put in a 1 for the 1 input, right? But that isn't going to work. And I can show you that won't work at P. And we would hope that that would be my U. But you notice we get an error because meta weight hasn't been updated to kind of handle this op input type of functionality that a lot of other functions have. I've put in the RFE. I hope someday they'll deal with that. So in order to do that, it wants a file. It wants a string name. It wants a file. So I'm going to give it a file. My file equals, and what we need to do is it needs to, and this is a little bit of a trick, and it gets people, and sometimes they can't remember. We want to make sure we're using the right thing. Sprint f, that's the function. Op colon %s, this is going to do some string concatenation for us, chs, and I'm just going to use a channel called f for the file. And if we hit this little plus button, we'll get our little f. It'll be down here, right? And I don't like them being at the bottom, so I'm going to move it up to the top because it makes it easier for me to see. I'm getting old. So I hit apply, hit accept. Now, I have a function called in, which is going to get me what I want. You guys can bring this in any way you want. I use in, and what in will evaluate to is the full path of this. And basically, what you could do is, I think it's, I forget exactly what the function is, but it's op full path. And I think you have to go // plus op input. Oh, maybe I can do op input path. Can I do that these days? Dot, and then the index would be 1. Does that work? So op input path dot /1. What does that evaluate to? Yeah. So that would work, right? So I think this should work for us now. So if I put this in my file, we should get that. We can see what that's going to be by going s at test file equals my file, just so that we can see what that evaluates out to. Spreadsheet. And you'll notice that that gives us this op colon and then the full path. So now one thing to do that's very interesting, well, we'll just look at this. This is how easy it is, right? So at cd equals my u. And there you go. And if we move this metaball around, T for moving it, it moves all over the place. And we can scale it up, scale it down, all sorts of great stuff. And if we merge in metaballs, again, I know I keep harping on this, but you know, we can take this metaball, move it just up, move it just off here, and you can kind of see they start. And again, they're functions so that you can basically erase one from the other, right? Go back to 2. And you know, again, this works independent of point count. So if we switch this over to here, it's really hard to see because we have a bunch of black points in the way. So we're going to put down attribute wrangle. I already have a function that kills these in my preset. So we're just going to kill points and make life easy. There you go. There are some metaballs being eaten away by like a mask, a 3-dimensional mask that we can move anywhere and do anything with. So one of the things that's great about this is let's do something here besides my p, right? So I'm going to make some noise. Vector my noise equals noise, and make this, I'm going to keep this simple, at p times something like, we'll keep it 1 for now, right? Then my noise plus equals, minus equals 0.5. That way it's 0 to 1. My noise times equals some amp. I'm going to try 3. I think 3 was kind of good for this scale. And now what we're going to do is I'm going to create one more thing. Well, I didn't like that. Paste, paste. Yeah, I just must have spelled it wrong. I sometimes spell things wrong. So I'm going to make one more thing. I'm going to call it my p equals at p plus my noise. And then we're going to put my p into the metaball function. Oh, got the that little guy. And maybe I'm spelling this wrong again. And what we should be able to see there we go. Now what we're seeing is we're seeing a noisy lookup to our metaballs. So all that took was just noising up the lookup. So instead of using P, I use my P after noising it up, and we get a noisy metaball field for our effects. And you know, you could do anything with that noise. You can animate it, move it around, whatever it is, and you notice we get this nice little kind of, yeah, works perfect. So there's a quick introduction to how to write your own first effects function with using a metaball. Okay, now that we've seen the first kind of use of using effects and metaballs together, let's start doing a little bit of tool building and really getting into some pillaging and plundering. So tab geo, we are going to write a meta interpolate, and we're basically going to interpolate the colors of metaballs. This could be expanded out into all sorts of other things, but for now we'll just interpolate the colors, because if you notice, we really couldn't get colors out of the metaweight function. The metaweight function didn't give us anything but the density, the weight, coming back with the weight of the metaballs, but not anything else. For now, I'm just going to steal all of this, copy, and just as a starting point. So we're starting in a similar location. And for this, one of the things that I'm going to do is I'm going to add some color. And you'll notice this doesn't give us any color. It's white is white, but let's make it red, 0, 0. And if we look, this is still white, but now we've got a white and, a white and red metaball. And we'll do the same thing, 0, 1. And we'll make a nice, copy both of these, copy, paste, up, and paste this over here, and paste that in there. We'll make this one blue, and move the blue one over a little bit, return, and T, and just move the blue one over. So we have a nice little kind of infrared rainbow section. If you notice, none of the colors come through. So let's say that you wanted to, interpolate some values. We can always, all of us Houdini people are clever enough to kind of put attributes into colors and colors back into attributes. And so being able to interpolate this would be very useful. So how do we do that? I'm gonna get rid of all this stuff, and we're gonna build our first tool. So we're going to start with a subnet, and we're just gonna create digital asset right away. I use a very specific sort of naming convention that came from SESI, and this is meta interp, and we'll make it 1. It's version 1, and this is going to save it into my. I'm on a Mac right now, so it's going to save it into my Houdini preferences, or my username preferences Houdini. So now we have it. We know we're going to at some point need 2 inputs because we're going to plug Metaballs into the side. And just like this tool isn't going to need too much. At some point, maybe I'll add some noise functions to it to noise up the interpolation, because that's always kind of fun. But I'm not going to do that today because we're running a little bit long on time. But so we'll make a control function here. And again, we're going to need that file name. So we're going to put in a string here. And put it into the controls. I like controls, apply. And we're going to call this input. And again, for a long time I've been using my own expressions. I know not everybody knows them, and it's good to learn this one. We'll start with the op colon for the server context. We'll go op full path, op input, op input path, and I think the context for that is this node. And what index do we want? We want the 1 index, and we hit apply and accept, and we'll just double check. Plug these guys in. These are going to be the points that we're going to be looking at. These are the metaballs we're going to be looking at. And so, yep, that evaluates out to this node. That's what I was expecting. Okay, so let's dive right in here, right? And we don't even need to input this because all it cares about is the file name. So we're going to put down a wrangle, attribute wrangle, and we'll just leave that as is right now. And so for the sake of trying to figure this out, this is where we pillage and plunder. So I'm going to go into Pop Network, and like I said, this is one of my favorite places to steal metaball code, is to go into Pop Metaball Force and allow editing of contents. And we're going to dive in there, dive into this BOP right here, compute metaforce. We're going to select all of this. We're going to copy it. We're going to go up, up, up. We're going to go back into our subnet, and I'm going to paste it all in here, and I should get an error. That's totally what I expected. I'm going to copy this and paste it, and this is going to be my backup, just so that if I really screw stuff up, I've got some place to come back to without having to navigate all the way around. So this is a lot of code. We're going to bring up the expression edit string. For some reason, my Apple E isn't working on my Mac. So right away, we notice that we have this op input, and we know that 0 and 1 won't work. So this thing needs that file, right? Remember that whole file thing? We just made that string path. So string my file equals CHS. And we already put the op in there, so this will be F. And we go like this and hit apply, and it's still going to give us a bunch of errors. That's okay. Go down here. Here's the F. Like I said before, oh, my son keeps asking me things. I love this about my Mac. So I am going to edit this, and we're going to put this on up here. Hit apply, hit accept. So the next thing that we're going to need is we're going to need this. So we're going to copy this bad boy, copy parameter, go back up here where we can see it, paste, copy relative reference. And that should give me that. That will now be this. So now I'm going to put this under here, and let's see what happens. My file. And I still get errors. Okay, well, let's just see if this part works, right? One way of doing that is to comment out all of the code, right? So we'll comment everything out. Oh, we're still getting an error about P. Well, let's take a look. Well, that makes sense because in a point VOP, P is a little different than in vex expression. So let's hit the P. Okay, so right away we know that, okay, now this is functioning. Let's hit this and see what we get. Oh, missed that. We got a great big ball. Okay, well, that's kind of what we expected. Now, this code we stole, it was doing some force operations. And since we don't need all the force operations, we're going to get rid of a lot of it and then fix some things. We know we got to fix the P's, but we also know we don't need the spiral. We're not going to bring in the Vortex Force. We just want to make sure we leave one meta import. So this meta import is really important. This is important. This really isn't important to what we're doing. This will be the template that we'll use. All the rest of this we're not going to use because we're just going to do color, right? So let's take a look at this. What we care about is CD. So instead of importing, first of all, let's fix the P's, right? So we know that these all have to be at P. And we know this has to be at P. And if we hit apply, we're still going to get that force has not been declared. And that's okay. We can declare something else up here. I'm going to explain this a little bit later, but okay, so here, let's do this. Instead of force, we're going to do at CD. And at CD is going to equal something I'm going to call my CD. We're going to bring in CD, and we're going to put CD into my CD. And CD is a vector, so we're going to redeclare that my CD vector my CD equals 0. We'll make it equal 0. So now if we look, what this is saying is declare a vector called my CD. Loop through the metaballs. Look for the attribute CD on the metaball at position P and put whatever that is into this. Then we're going to set CD to my CD. And if I hit return right now, I feel pretty confident I shouldn't get any errors. Let's take a look at what this gives us. We get a great big white and black ball, right? There's some white points and there's some black points. So what's going on with that? Well, one of the things that's really important to know is that we right now the way that the attributes are put on is kind of in an unpre-multiplied way. So if we go back here, expressions, edit, string value. Let's go edit, expressions, edit, string. Okay. One thing that we might want to think about is that CD needs to be multiplied by the density of the metaball. Now, one thing we also might want to take into consideration is, well, we'll leave it like that. So you remember the weight can be pretty high. So, but we'll do density of the metaball. See what that gives us. Multiply by the density of the metaball. Hit apply, hit accept. Now what do we see? Well, we see some white and we see some black. Something else is just not quite living up to what we think, right? So one of the things, let's look at this again. We're in a loop. And what's happening is every time we run through, this is run through the first metaball, run through the second metaball, run through the third metaball. So what's happening there is whoever the last metaball wins, and some of the points aren't in any of the metaballs. And since we're setting it to CD, and CD's never been declared, Houdini has a tendency when CD hasn't been declared to set it to white, which is probably the least harmful thing to do. But we don't want one metaball clobbering the last metaball. What we really want to do is to sum them up. So in order to do that, what I'm going to do is I'm going to go vector my CD sum equals 0, right? And so instead of setting CD here, what I'm going to do is my CD sum plus equals my CD. And here at the end, I'm going to set at CD equals my CD sum. And this is going to solve two problems. One, it's going to start black. So if we never in a metaball, we're going to be black. If we are in a metaball, we're going to take whatever this metaball was, whatever this metaball is, and sum it up with the last metaball, the previous metaballs. And so let's take a look at what this does. Did we get any errors? Nope. We can accept that. There we go. That's what we're looking for. You know what I mean? And we'll put out, put an output here on our tool. Out. And yep, go up. And again, we could add all sorts of noise functions to this or whatever. You know, there's a kind of an easy trick to adding noise to this too, is adding a rest position. Add, you know, what a mountain stop, I guess, you know. So the mountain is that going to give me some sort of height scale? Sorry guys, I'm going to use my own noise stop tab. I have a noise stop that I particularly really like, and we're just going to drop this in real quick. And we're going to go to position. I'm going to amp this up a little bit. Oh, we want to add, just amp this up. Give us a little bit of scale. There we go. And then if I go like this, wrangle, attribute wrangle, and I go at P equals at rest. At P equals at rest. It'll go back to its rest position after noising it up. And you can see we can noise it up. I turn this off, no noise, a little bit of noise. And if you look, the metaballs move around. And just to give you an idea of what that transform stop looks like, let's take this out. We'll scale this out, right? Scale the metaball out. And one thing about metaballs is, and we'll set the pivot, center expression. Basically, that little preset made it so that the pivot is at the center. If we take this guy and rotate him, all of that X-form code completely 100% respected these rotations. So super cool. And again, I think we can take these metaballs and really crank them up, the weight, and you see they keep adding up. Yeah. So there you go. That's a quick and easy way to steal a little bit of code from Sesi and build a tool that isn't quite there, but could be really handy for a lot of different things. Thanks for watching. We'll get on to the next episode in just a minute. Okay, now that we've made a meta interpolate, let's build our next tool, which is going to be a meta deformer. Again, this is a tool that I think Sesi should build for us, but being, you know, this being Houdini, we can build our own. And this is something I think people have overlooked or has been overlooked, but I think it's a great way of building a deformer. So I'm going to take my standard pig head, I'm going to mess him up a bit and convert him, and we're going to subdivide him a bit so we have some polygons to play with, maybe up to a level of 2. Let's see what that looks like. Yeah, that's quite a bit, maybe 3. I'm going to make it really dense. Okay, great. So we'll put down a little metaball. And the way that I'm going to build this deformer, since I already know I've got some good code for the pop metaforce, I'm just going to use forces. So at first, we're just going to leave it here, turn on the axial force. So this is going to say in Z, move stuff. You put a force on things along the axis, this much in Z. We'll merge it in case we have more than one metaball at some point. The other thing I'm going to do is I'm going to put down a transform stop. And like anything, metaballs respect this transform. We'll zero it out for now, but I'll show you a little bit later why that's kind of cool. Let's build our tool. So start with a subnet and create digital asset. And again, I like this naming space stuff. I'm going to call it a meta deformer and give it version 1. And this will be V. And we'll go here and go like that. So now we've got the tool. And we know that we need 2 inputs. We know that we're going to use the same sort of, we'll make a controls folder. And we know we're going to need a string for the input. This could be called meta input, but I'm just going to call it input for now. You guys go to build your own. I'm sure that you'll come up with really good naming conventions for all this. And again, this is like that expression that we're going to need, which is the server context, and then op input path, which node, this node, and which index do we want? We want the 1. Hit apply, and if we plug this in here, and we plug this in here, and we check it with a middle click, we're getting that merged 1, which makes life good, so we're getting the right thing. I'm going to put in just 1 extra controller here. We could go nuts and put in all sorts of controllers to control how much of this kind of deformation we're going to do and how much of that deformation we're going to do. But for the sake of this video and for the sake of just kind of being fast or faster, we're just going to call this overall amp, right? And copy tab, and we'll paste that, and we're going to make that kind of a 0 to 1. And put that in there, and we'll default to it being on. So we'll default to it being on. And again, a lot of this is going to be based on pillaging from side effects again. So we're going to put down a pop network. I'm going to put down a pop metaball force. Allow editing of contents. Right click, allow editing of contents. Dive into here. And we're going to take all of this code, select all, copy, go up, 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 back into our tool, in, put down an attribute wrangle, and just paste this code in, paste. Remember, we're going to need that file, so we might as well just put that in now. So I like using so we got a string, I like it being on top. Oops, went to the bottom anyway. I guess Ceci likes it being on the bottom. I like it being on the top. I'm going to just call this F, apply, F for file. And we're going to go up and grab this guy. Copy this. Oh, I guess there's an O too. We might as well put the O in. Paste, relative reference. Or here, we might as well put in the O. So another float right here. And we'll just call this O for overall. Make these things easy. Go up. Copy this. Go back in. Paste, relative reference. Okay, so now we got that channel, that channel. That should be good. Okay, so we're going to look at this code. In some ways, this is actually going to be a little bit easier than the last one we made. So we know that this needs to be my file. So we'll go here, go string my file equals ch, and we already put in all that server stuff. So we just need the F, and that will give it to us. We'll go in here, this op input, and we'll make this my file. And we know that if we hit apply, we're still going to get an error. See this P. The P isn't defined because we're doing expression code. We need to do the P's. I know that I could use the search and replace. Now, probably would be faster, especially for those of you that are like, oh my God, this video is going forever. But it's good for me to always just kind of get used to the idea of looking for things. It helps me practice debugging. You know, when you start writing a lot of code, being fastidious is good. So now if we hit apply, we're still going to probably get another one, which we don't have. Force isn't. Oh, I missed a P. Oh, where did I miss that P? Oh, up here. So we'll redo that. That's why we look. Teaches us. Now force isn't well defined. And if you guys remember from the last video, we needed a CD sum. In this case, I'm not going to make a force sum. Force is one of those variables that Houdini has internally in the pop context, but in SOP context it doesn't. So we're going to define it up here, force equals 0, and that's basically going to act like our force sum up, right? So we hit apply, and now we don't have any errors. And if we look, nothing happened to our pig. Well, that's because we haven't affected P yet, right? So I'm going to do something here where I'm going to say, remember we had that overall multiplier, so force is going to times equal CH. We made that O variable, that O channel. So still nothing's going to happen. But what happens if we go at P plus equals force? Okay, I'm going to move this off to the side, and I'm going to hit apply, and boom, there we go. Already, we've got something. So I'm going to put my output and out down. Out. Come up. And so, look at this. Right away, we've got deformation of the pig. And the cool thing is, remember I told you, this thing respects transformations, right? So if we move it, it's great, right? Okay. So, very, very nice. Now, the other thing that we get built in for free is when we turn off the directional force, we can put on a radial force and blow them up. Remember, this is suck in. One is suck in from the force, and this is out. So if you want to blow them out a little bit, blow them out, right? Starting to look like elephant pig. Let's go back to the radial force. You also get things like Vortex Force. And let's see what happens here. Oh, we're spinning this guy, right? So if you look, you're starting to get a little bit of a vortex, a little bit of spin here, a little bit away from the thing. Now on a pig, this looks gross. Let's do another quick example here, right? Tool's already done, so we'll save node type, match current definition. And let's try another quick example, and then we're going to cut this video short. I just don't want this to go too long, right? And it took me a while to set this up right because I haven't done it in a while. But let's give ourselves a grid with 200 by 200 samples, and we're going to put down a metaball. And the first metaball we're just going to make kind of long and skinny, and we're going to put it down just a little bit. And just put down our meta deformer that we just made. Our meta deformer we just made. Meta deformer. And put it in here. And oh, we forgot something very important, to use the force. Use the force, Luke. And we're going to, on this first meta deformer, what we want to do is we're going to push everything up in Y just a little bit. And so just something like this, you know. And if we put down a transform here and transform this, you know, like if I was in California again and I saw this coming at me from the horizon, I would start getting a little excited because that's starting to look like, oh, let's make it look a little bit like an ocean wave here, huh? Nice little Caribbean blue. So there's the beginning of something, but you know, waves have a tendency to curl on themselves. They're not just lumps in the sea, they curl on themselves. So we're going to do a little trick here with a feedback, for loop with feedback. We'll just log this in like this, and I'm going to take this guy, and for the sake of just keeping things locked together, I'm going to create a reference copy of him over here and making my life easy again. I'm just going to copy and paste these two guys. I'm going to plug him into here, and I'm going to make sure I don't touch this guy. Oops, Control Z. Make sure I don't touch him by coloring him something dark. You know, don't touch. I'm probably going to have to tweak this one around in space a little bit. So this is the good one. And I'm going to put my little expression on this, centroid expression, so the center's on there. And I'm going to put down another meta deform. Oh, the wrong one. That one's mine from before. put down a little meta deform that we built, which is this one, and put him into the middle of this and plug him into this guy, Bink. And let's see what this looks like. Okay, so first of all, this force, we don't want to go up. If we look, X is kind of the direction that things are flowing in. So I'm going to set this to 0, set this to 1. I don't want it to move along the axis, but what I do want it to do is I want it to rotate around the axis some. So if we look, a little bit of rotation around the axis, and you notice that's starting to get a little bit crazy. So we'll just, a little bit of this is going a long way. So, because we have it in a feedback loop. Okay, so let's do that and see what that gives us. So we're starting to get a little bit, and a little bit of a spiral force. So the spiral out, vortex around. Right, so now what we're seeing is this vortex is really cranking. Let's move this guy up a little bit. T. Oh, there we go. And maybe T this way a little bit. There we go. Go up a little bit. And now we're starting to see what's starting to look a little bit like a good old-fashioned curling wave. And I'm sure if I spend some time to really dive into getting just the settings just about right, spread out like this a little bit more, that's starting to look like a surf logo. And again, these things respect rotation. So if I go like this a little bit, we can get a little bit of that leading edge kind of surf, you know. And again, with the force, you know, more curl, less curl, all these things are animatable. All these things are animatable, and this will spiral it out a little bit. You know, sometimes you got to add a little spiral, a little push away or push in, suck in, push out. And with this original kind of guy over here, you know, we got a wave that's just kind of cruising up into our, cruising up onto us. So again, really great way of making deformers and doing all sorts of cool, fun stuff with just simple code that's already sitting there. It's kind of just knowing how to steal it really makes a difference.